This legendary fighter escorted heavy bombers deep into enemy territory, breaking the Luftwaffe's back with a distinct scream. That became the definitive sound of Allied air superiority over Europe. Wingspan spans 37 feet, equal to the width of a doubles tennis court, giving the platform stability at altitude while retaining the roll rate needed for snap maneuvers. Combat weight hits 5 short tons, comparable to a medium military truck, requiring substantial engine power to accelerate the aircraft off the runway and into thinner, upper atmosphere. British purchasing commissions initially sought an existing American fighter, but the manufacturer proposed a completely fresh design that could be produced rapidly to meet the urgent European need. Planners required a long-range escort to protect daylight bombing raids, as previous fighters lacked the fuel capacity to follow the heavy formations all the way to their targets. Designers rushed the prototype from paper concepts to a flying machine in just 102 days. A frantic pace that relied on proven engineering experience rather than lengthy testing cycles. Engineers selected a laminar flow wing profile, moving the thickest part of the airfoil further back to reduce drag and increase speed compared to conventional fighter designs. The team placed the radiator intake under the fuselage belly rather than the nose, a risky decision that ultimately improved aerodynamics and pilot visibility over the forward cowling. Factories utilized advanced mass production techniques, breaking the airframe into major sub-assemblies that could be built simultaneously before final mating, which accelerated delivery and to the front lines. Construction follows an all-metal, semi-monocoque philosophy, where the outer aluminum skin bears much of the structural load, reducing the need for heavy internal bracing throughout the fuselage. The fuselage consists of 3 main sections: engine, mount, main cockpit, and tail cone, bolted together to allow for easier maintenance or replacement of damaged segments in the field. A heavy main spar runs through the wing center section, providing the critical strength needed to withstand high G pullouts during intense dogfights or steep dives after enemy aircraft. Flush riveted aluminum skin covers the airframe to minimize surface friction, a detail that requires precise manufacturing standards to ensure the laminar flow over the wings remains undisturbed. The tail assembly features a conventional layout with a vertical stabilizer and rudder connected to the fuselage by strong fittings that handle the stress of violent yaw maneuvers. Landing gear retracts inward toward the fuselage centerline, utilizing a wide track that significantly improves stability on rough grass airstrips common at forward operating bases across the European theater. Early models struggled at high altitude, leading engineers to replace the original domestic engine with a British-designed V12 that transformed the airframe's potential and combat ceiling. The Packard V1650 Merlin engine serves as the heart of this beast, a liquid-cooled powerhouse licensed for American manufacture to bring high-altitude performance to the existing airframe. A 2-stage, 2-speed supercharger compresses intake air, allowing the engine to breathe efficiently in the thin atmosphere where bombers operated, maintaining power far above 20,000 feet. This mechanical marvel delivers over 490 horsepower at takeoff, driving the fighter with enough thrust to outclimb most adversaries it encounters in the skies over Germany. A 4-blade constant-speed propeller converts engine power into thrust, adjusting blade pitch automatically to maintain optimal RPM during climbs, cruises, or high-speed combat dives. The belly scoop utilizes the Meredith effect, where heated air expands and exits the rear duct to generate a small amount of jet thrust that offsets radiator drag. Stubby exhaust stacks protrude from the nose cowling, directing hot gases backward to provide a small amount of additional thrust while keeping noxious fumes away from the pilot. Efficient fuel consumption allows the engine to run lean during long escort legs, conserving precious gasoline until the moment combat power is needed to engage enemy interceptors. A high-pressure hydraulic system actuates the landing gear and flaps, using fluid mechanics to manipulate heavy control surfaces that would be difficult for the pilot to move manually. The electrical system relies on a generator driven by the engine, powering cockpit lights, gun sights, and radios, ensuring the pilot remains effective during long missions. An onboard oxygen regulator mixes breathing air for the pilot, a critical life support system, preventing hypoxia during missions that often take place at extreme combat altitudes. High-frequency radios allow communication between squadron mates and bomber crews, enabling coordinated tactics that turn individual fighters into a cohesive and deadly fighting unit. Internal fuselage tanks carry the primary fuel load, but this distribution affects the center of gravity, requiring pilots to adjust trim as the gasoline burns off during flight. Offensive bite comes from 6 machine guns mounted in the wings, set in staggered positions to accommodate the ammunition belts feeding through the internal wing structure. These are .50 caliber weapons, firing heavy slugs that tear through enemy airframes and engine blocks, with kinetic energy capable of shredding light armor and fuel cells. Gun bays are accessible from the top of the wing, allowing armorers to rapidly reload ammunition belts and service the breaches between sorties on busy airfields. Ammunition capacity varies by gun position, with the inboard guns holding more rounds, ensuring the pilot retains firepower even after the outboard weapons run dry. Underwing hardpoints carry external stores, capable of hauling drop tanks, bomb loads, or rocket tubes for ground attack missions after escort duties are completed. Electrical heaters wrap around the gun breeches to prevent the mechanisms from freezing solid in the sub-zero temperatures encountered at 30,000 feet over Europe. Later variants utilize the advanced K-14 computing gun sight, which projects a gyro-stabilized reticle onto a glass reflector plate to help pilots calculate correct lead angles. The pilot dials in the wingspan of the target aircraft, allowing the analog computer to adjust the aiming ring size based on the range to the enemy. Cockpit switches arm the weapons and select firing modes, giving the aviator control over whether to conserve ammunition or unleash a full broadside against a target. A simple trigger on the control stick activates the solenoids, firing the guns instantly and requiring a steady hand to keep the nose tracking the target. A single pilot sits in a cramped cockpit, surrounded by dials and levers, managing navigation engine settings and combat awareness without assistance from crew members. The bucket seat is designed to accommodate a parachute pack, which serves as the only cushion between the aviator and the vibrating metal frame during long combat missions. A bubble canopy on later models offers nearly complete visibility, removing blind spots of earlier Razorback designs and allowing the pilot to check his 6. Controls are arranged for ergonomic efficiency, with throttle and propeller pitch levers on the left quadrant and the stick in the right hand. Heavy steel armor plating mounted behind the seat and a bulletproof windscreen provide the only physical protection against enemy fire, effectively shielding the pilot's exposed head and torso. Startup involves priming the engine and engaging the inertia starter, causing the propeller to slowly turn before the cylinders catch with smoke and thunder. Takeoff requires careful rudder input to counter propeller torque, which tries to yaw the aircraft off the runway centerline if power is applied too rapidly. Pilots climb at a steady airspeed to reach bomber altitude, constantly monitoring engine temperatures to avoid overheating the liquid-cooled system early. Cruise requires constant fuel management, switching between tanks to maintain balance, and dropping external stores only when engaging enemies or when tanks empty. Releasing the external drop tanks instantly improves aerodynamics, dramatically transforming the aircraft from a sluggish, fuel-laden escort into a nimble fighter fully ready for immediate aerial combat. Landing is demanding due to the laminar flow wings' stall behavior, requiring a powered approach and precise speed control to touch down safely. Top speed reaches 437 mph in level flight, allowing pilots to dictate engagements by overtaking interceptors or disengaging at will. Service ceiling exceeds 40,000 feet, giving the aircraft the ability to attack from above using altitude and gravity as weapons. Ferry range extends beyond 600 miles with external tanks, enabling fighter cover to follow bombers deep into hostile territory. Pilots employ boom and zoom tactics, using speed and dive performance to strike quickly rather than turning with more agile opponents. The airframe retains energy well in high-speed maneuvers, allowing it to remain effective longer than lightweight fighters that bleed speed rapidly. Compressibility becomes dangerous in steep dives, where shock waves form over wings, potentially stiffening controls and requiring careful recovery. This legendary aircraft broke the Luftwaffe's ability to defend the Reich, successfully clearing the skies for massive Allied bombing campaigns that systematically dismantled the enemy's industrial infrastructure. Beyond its primary escort duties, it excelled as a lethal ground attacker, utilizing superior speed to destroy locomotives, supply trucks, and parked aircraft across the occupied European countryside. Service continued well after the war ended, with the robust airframe seeing intense combat in Korea and operating within air forces around the world for many decades. It remains the definitive ultimate symbol of piston engine fighter performance, standing as the peak of aeronautical engineering before the jet age arrived to reshape aerial warfare completely. From long-range escort to ground attack, the Mustang proved that true aerodynamic efficiency and raw engine power combined to create a timeless and legendary weapon of war.